All right, we got a quiz coming up, and this is our review for it. So as like always, just fast forward through the video if there's anything that you just want to jump to, or what I would recommend is you watch this video multiple times over, so you kind of understand what you're doing for the quiz tomorrow. All right, so starting with number 1, consider the following equations. Now, which of the following statements is true? And we see the sentences are like, the slope of both lines are the same and the y-intercepts are different. The slopes of the lines are different, the y-intercepts are the same, or both slopes and y-intercepts are the same, or slopes and y-intercepts are different. And what we're going to do is, obviously, we're going to follow our hint, convert both equations to slope-intercept form first. So let's give that a try. So when we do this, right, let's look at equation A for a second. Let me do it over here on the side. So equation A, we have 9x minus 3y equal to 6. So when we convert this, we're looking to get y by itself. That's the goal here. Get y by itself. So that's what you're going to have to do in your quiz as well. Get y by itself. So in order to get the y by itself, we're going to have to cancel out the 9x. We're going to have to try and cancel out the negative 3 here as well. So we're going to start by moving the x term. We always kind of start by doing that. So if you want to follow this process, step 1, say move x term, okay? Move x term. Follow this step on the quiz tomorrow. So because it's a positive x term, we're going to subtract it. It's a 9x, so we're going to subtract 9x. Now, when I subtract it and I cancel it out over there, I have to do it on the right-hand side of the equal sign as well. So what this leaves me is on the left side, the 9x minus 9x becomes 0, goes away, cancels out. So I'm just left with the negative 3y equal to, and on the right side, I have 6 minus 9x. I'm going to go ahead and write this as a negative 9x, because that's what it is, and a plus 6 because it's 6 is positive. So I'm going to write it with the x term first. That's preferenced. It's a preference to do it that way, because you have more of the mx plus b look to it. Whereas if you wrote the 6 minus 9x, then, it might confuse you, might not, I don't know. But I'm going to leave it like this. We're not done yet because we still have to get rid of the negative 3. Now, we're not going to add 3 because this negative 3 is not being subtracted onto y. This negative 3 is being multiplied onto y. So in order to cancel it out, we do the opposite of multiplying, right, which is dividing. So I'll divide by negative 3, and that's going to be the proper way to cancel it out. Now, since I divide this by negative 3 to cancel it out and leave y by itself, I have to do that to the other side of the equation as well. So both of these terms are going to get hit with dividing by negative 3. Now, what that turns into is negative 9 divided by negative 3 becomes a positive 3, and that's my x term. And then positive 6 divided by negative 3 becomes a negative 2. So that'll become a minus 2. So there's our equation. Here's our y all by itself, and equal to mx plus b. Now, it's not a plus, it's a minus, but that's fine. So what this indicates to us is that 3 is our slope, and negative 2 is our y-intercept. Now, we still have to figure out what the other equation is. The other equation, we have to know what its slope and y-intercept is. So we're going to have to rearrange it as well. So it is negative 2x plus y. Negative 2x plus y equals negative 3. Right, okay, negative 3. All right, so we're going to do this one. We're going to try and solve it for y. Remember, get y by itself. Step 1 was move x term, and then step 2 was divide number from y. That was step 2. When I say that, I'm talking about the dividing of negative 3 in that problem. So the first one was the minus 9x. Second one was divide by the negative 3. Those are the only 2 steps that you need to get the y by itself. So here, we're going to follow the same steps. We're going to follow step 1, which, remember, is move x term, right? Move x term. So that's the negative 2x in this case. Now, because it's a negative 2x, we will have to add 2x, because negative 2 plus 2 will cancel out. Now, again, since I did that on the left, I have to add it to the right-hand side too. So this leaves me with y equal to, and same as before, I'm going to write the x term first. So it's a positive 2x, so positive 2x, and then it's a negative 3, so minus 3. All right. So here's my slope and y-intercept, okay? It's in mx plus b form, which is perfect. This tells me that the 2 is my slope and the -3 is my y-intercept. So on the first one, the slope was 3. The y-intercept was -2. On this one, the slope is 2. The y-intercept is -3. Now, in this case, both of my equations have different slopes, right? Slope of 3 in the first one, slope of 2 in the second one. So different slopes, and the y-intercept are different as well. We have -2 in the first equation. We have -3 in the second equation. So the slope and y-intercept are both different. So in this case, we'd be talking about answer choice D would be the correct answer. All right, so now we have the responsibility of graphing these lines. So let's graph equation A first. Equation A, which I'm going to highlight here in blue, and I'm going to write it with, I guess I'll write it in this purple. All right, so its y-intercept is -2. We just talked about that. So on the y-axis, we'll go down to -2. So that's -1. This will be -2 down here. So we're going to put the y-intercept right there. Remember, this is the y-axis in the middle, x-axis along the side. Okay, so there's my y-intercept. Now my slope is 3 for this line, which means it's 3 over 1. So we're going to go rising 3. So we're going to go 1, 2, 3, and then we're going to go running 1, which is here. Puts my point there. And I'm going to do it again. Go up 3, 1, 2, 3, and then over 1 right there. All right, and if I want to go backwards, I can go down 3, 1, 2, 3, and then left 1, and I get the same pattern. All right, so there's my line for equation A. Now let's do the line for equation B. Equation B has a y-intercept at -3. Okay, so -3 is going to be right here. And it's got a slope of +2. So its slope will go up 2 and over 1. Because the slope being +2, same thing as 2 over 1. So we're going to go up 2. So 1, 2, and then over 1. It puts us right here. And then we're going to do it again. Go up 2, 1, 2, and then over 1. Puts us right there. Go up 2 and over 1 will put us here and here. And if I go down 2 and left 1, that'll put us overlapping this other point on that line. So that line would look something like this. That's equation B. That is line B. So equation A, line A, and equation B is line B, this one here. All right, and that is the graph for those. So you'll have to remember to repeat this process on the quiz tomorrow. Okay, it's going to be very, very important that you do the math and to get each equation in slope-intercept form like we've done for the first one and the second one. Very, very important that you can do that because obviously the whole problem relies on that. It's 2 questions right there. 2 questions that rely on you being able to do that. So that's a big chunk of the test or quiz, whatever you want to call it. All right, problem number 3. Aunt Maggie's car broke down on Interstate 10. Let's go back to the purple here. Sam's Towing charges a $65 hookup fee and a $3 per mile towed. Regina's Towing charges $55 hookup fee and $3.50 per mile towed. All right. Now, on the test, you'll see this being one of these types of questions. But in this case, we're just actually going to find out all this different information. But on the quiz tomorrow, it'll look a little different. You won't have to fill it in. You'll just have it filled in. You kind of have to say which ones are true, which ones are not. So the function for Sam's Towing. So Sam's Towing, $65 hookup fee and $3 per mile. So Sam's Towing will be like y equals, and if it's, you can write it a couple different ways, but I'm going to say I'll follow the train of thought here. It's got $65 hookup fee plus the $3 per mile. So you can have the equation look like that, or you could write it as y equals $3 per mile plus 65. Either way is just fine. I'll leave it like this for now. So Regina's towing is $55 hookup fee and $3.50 per mile. So it'll be $55 for the hookup fee plus $3.50 per mile. So the y-intercept. The y-intercept for Sam's is 65. The y-intercept for Regina is 55. Because those are the kind of the flat fees, the fee that they would pay at the very beginning. The slope for Sam's towing is 3. This is because it's changing $3 every mile, $3 per mile. So the slope represents the miles, or I'm sorry, the dollars per mile. And Regina's would be $3.50. Because obviously hers is going to be $3.50 per mile. The rate of change for both, in this case, would represent the money charged per mile. That will be the rate of change here, because that's what the $3 and the $3.50 represent, right? The amount of money that's being charged per mile. Okay, now number 4. So Fred bags groceries at Wegmans. On average, he fills 20 bags every 4 customers. So on the graph below, represent the total bags Fred filled based on number of customers. So a couple ways you could do the graph. The way I'm gonna write my axis. So on the bottom will be customers. He helps. And on the y-axis, it'll be bags. Now, our slope essentially is going to represent our rate of change. Will represent essentially bags per customer. Meaning that bags would be my change in y, customers would be my change in x. So that's why I wrote customers on the x-axis, bags on the y-axis, in case you were kind of confused as to why I did that. And since we're going to go up by quite a bit, I'm going to go by 2s here. I'm going to go with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And on the y-axis, I'll go by maybe 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. You might want to do it a different way. It doesn't really matter as long as your points are accurate. So let's graph what we have here. We know if it's 20 bags every 4 customers, right? 20 bags every 4 customers. Essentially, this is going to be 5 bags per customer. So one customer would be 5 bags, which would make 2 customers 10, 3 customers 15, 4 customers 20, 5 customers 25, 6 customers 30, and so on. So I'll just go by 8s or by 2s here. So 8 would be 40 customers, 10 would be 50 or 50 bags, 10 customers 50 bags. I might have been saying that backwards. I apologize. 12 customers would be 60, 14 would be 70, 16, 80, and so on. There's a line for my graph. Again, your line might look different. It depends on the way your axis is written. Because if you write your axis even a little bit different. So let's imagine I wrote my axis by 1s and 5s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I wrote it by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, then it'll look similar. 2, 10, 3, 15, 4, 20, 5, 25. It'll look similar. But there's so many. It kind of depends on your axis. Because if I go by, let's say go by 10s again, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Right? One customer would be 5, 2 would be 10, 3 would be 15, 4 would be 20. Right? So it might look a little different. It all depends on sort of how you decide to label your axis. It's still the same graph because the points would still be the same. 4 customers would still be 20 bags, 3 customers would still be 15, 2 customers would still be 10. So, all those points are still the same. It's just the axis might be labeled a little different. So, but either way, it's going to be a line. It's going to be a straight line in this problem. What does the average rate of change represent? So the average rate of change represents bags per customer. We've mentioned this already. That's how I knew to establish bags as the y-axis and customers as the x-axis. What is Fred's average rate of change? So in this case, we already mentioned it. If he gives 20 bags per 4 customers, then this is going to equate to 5 bags per customer. So 5 bags per 1 customer, right? Per customer. All right. And now number 5. Brandon and his friend Adam both paint houses. Brandon earns $425 per week painting 25 houses, while Adam earns $540 per week painting 20 houses. Construct a graph to represent both their earnings. Okay, so I'm going to have houses as my x-axis, and then we'll put dollars as my y-axis. Because essentially what we're looking for is how much money they make per house, right? So that's going to be my y and my x. That's how I knew to put money as my y-axis, houses as my x-axis, similar to the last problem. So I'm looking at these numbers. So houses, I'm looking at 20, 25, right? So my x-axis is going to have to go up to at least that. So what if I went by... what if I went by 4s? I guess I don't think 2 would work, right? 2, 4, 6, 8, 10. Yeah, 2 wouldn't work. So let's go by 4s down here. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. All right, and let's go by, so the money, we have to go 425, 540. So can I make it by 50? 50, 100, 200, 300, 400, 500. Yeah, I can go by 50. That would work. It'd be barely work, but it would work. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, and then at the very top, 550. All right. So let's find the rate of change per person. So Brandon, right? Brandon has $425 per week, per week for 25 houses. So if we divide that, this comes out to be 425 divided by 25. That'll be $17 per house. $17 per house. All right. And then who's the other guy? Adam. So Adam makes 540 over the course of 20 houses. So if we simplify that, 540 divided by 20 is 27. Yeah, okay. So he makes $27 per house. All right, so now we just need to graph this. My axis is kind of rough here, but we can make a general idea. So let's see here. Since I'm going by 4s on my x-axis, so let's see if Brandon were to do, he's doing $17 per house, right? So if he did 4 houses, that's 4 times 17. 4 times 17 would be $68. If he did 8 houses, 8 times 17 would be $136. If you did 12, 12 times 17 would be $204. If you did 16, 16 times 17 be 272. If he did 20, 20 times 17 is 340. If he does 24, 24 times 17 would be 408. Right, if he did, let's 28. 28 times 17 would be 476. We'll stop there. So if you're wondering why I'm doing that, it's because I labeled my x-axis by 4s. So that's why I went ahead and got these by 4s. And now I'm going to just plot those points. So 4 was 68, so it would be somewhere just a little bit above 50. Right, this is just going to be a little bit of a guesstimate, but it's all right. 8, 136, so 8, 136. 12, 204, so a little bit above 200. 16, 272, about there. 20 would be 340, which would be right about there. 24 would be 408. And 28 would be 476. So there's a little bit of a sketch for Brandon's. Now we'll try to do the same thing for what's his name? Adam. So Adam was $27 per house. So 4 times 27 is 108. 8 times 27 would be 216. 12 times 27 would be 324. 16 times 27 is 432. 20 times 27 is 540. This is all we're going to be able to fit on our graph. So 4 is 108. 8 was 216. So about there. 12 was 324. 20 was 16 was 432. And 20 was 540. So that's a kind of a sketch for atoms. So there's our lines, right? Basically, it doesn't really matter how you label your X or your Y axis. Just make sure you have enough information to kind of fill in what we got here. And then just make sure you have points that can fit on your graph. You don't have to go by ones every time. You can just go by whatever you labeled your x-axis as. So there's that freedom. But you see how we did it. We found the rate of change per house. We know that Brandon was 17, so we just did, all these numbers times 17 to get those points. And, Adams was $27 per house, so we just did all these numbers times 27 to get those points, and we were able to plot them on the graph. Or, to the best of our ability, sort of get them on the graph. What does the average rate of change for each graph represent? So the average rate of change represents, of course, the money made per house. And who has a greater average rate of change? In this case, it's Adam. You can see Adam's line is a lot steeper than Brandon's because he makes $27 per house, whereas Brandon only makes $17 per house. So Brandon's is definitely greater. I'm sorry. Yeah, no, Adams is definitely greater. I said that wrong. Adams with a whopping $27 per house compared to Brandon's 17. So there it is. That is the quiz review for you. I hope you guys have, good luck on your quiz. If you have any other questions, let me know. Rewatch this if you need to sort of help you understand it. It's very, very important that you get it down because quizzes make a big difference on your grade. So let me know if there's any more I can help you guys. I'll see you guys later.